Hello there. I just want to issue a little bit of a warning about this section. So, what I'm going to do is go through a rather, I would say, challenging paper, academic paper that describes how the time domain thermoreflectance software typically works. And it'll be somewhat challenging. I'm going to do my best to explain it not line by line, but explain some of the more challenging aspects of it. But it's not for the weak of heart, and it will require some intellectual effort on your part as well. So the goal is really to go through what's under the hood of time domain thermoreflectance software. And my word of warning is that a very new user who is just trying to get a basic idea of TDTR or trying to learn the ropes may want to come back to this part later and treat the time domain thermoreflectance software as a black box temporarily. So, you may be coming swinging like a knight, but it is actually quite reasonable to be afraid of this section, I think. Come back to it as you're ready for it. I'll just explain in this one slide some key aspects of what I'm going to do. So I'm going to go through a foundational paper by David Cahill that he wrote actually after some of his key papers on time domain thermoreflectance had come out, interestingly enough. But it's basically an analytic solution or an exact solution to the diffusion equation subject to Fourier's law. And it is surprisingly general. So basically the software is based on an exact solution to a multi-layer you pretend like you have a multi-layer sample. It can be anisotropic. You can do this with very general way, but that specific paper is probably only extensible to axisymmetric anisotropy. So like a through plane thermal conductivity being separate from like an in-plane thermal conductivity. And it treats all of the laser spots as Gaussian shapes. Which is a pretty good approximation for most lasers. That's basically it, and it's quite a there's a lot of little steps in this paper that are left out of the published version. So my hope is to sort of help you walk through some of the more challenging points of that paper to understand exactly what's in the software. And I would note that if you're going to do any TDTR for any period of time, most of the time domain thermoreflectance software or time domain thermoreflectance theory papers that I've seen have mostly been extensions of this paper. So you really need to understand every line of this paper in order to make contributions that go beyond this, I would say. So this is a pretty good it's a pretty good foundational paper.